Hi everyone. Today we are going to talk about streaming ingestion using Microsoft Fabric. Now here we would mostly be focusing on the Delta table and the Lakehouse as a destination, and we would be taking the data from various event sources. In my last video, I had a discussion about data lake implementation. Now in the data lake implementation, there are two type of ingestion that we generally take care of. One is the batch ingestion where the data is being refreshed in the data lake probably twice in a day or you know one time in a day. In the streaming ingestion pattern, what would happen that at the source side we would be having uh, some event generator or file generator which would be sending the data to our data platform system continuously, and in our compute layer we need to take that data and get that data ready for the consumption. So I have already written a blog explaining the streaming patterns that we are going to talk about today. Now, the demo that we are going to have today, it's totally based on this blog. I'm going to put the link in the description so that you can follow that as well. So in this blog, I'm going to talk about three patterns. In the first pattern, there is going to be an event generator which would be ingesting events continuously to our system, and we need to take that data and process it. In the pattern two, what we'll do, it is going to be the same type of source, same type of destination, but in the middle layer, we are going to use a different technique to process the data, which is called Spark structure streaming. And in the pattern three, that source where we had the event in the last two pattern, here we are going to replace the event with, let's say, some small files. We might be having some application which would be sending very small files to our storage account. Now, how we can process those data incrementally and continuously. So that is something we are going to look into in pattern three. Now in Microsoft Fabric, we already have a feature called real-time analytics. Now, if you look at that real-time analytics feature, it's a very good feature. Probably in some other video, I'm going to discuss about that. Um, we can do a lot of things using the real-time analytics. But in today's video, we are mainly focusing on the Lakehouse, like how we can get the stream data into Lakehouse. What would be the purpose? The purpose might be, let's say, if we look at the Lambda architecture, we already have the batch, uh, pattern created. We got some data into our data lake. Now, if we can just create one pipeline using the streaming pattern and get the streaming data as a delta table, and then we can do the joining between our batch delta table and stream data table and get some report out of it. So let's look into the pattern one. Here we are going to use the Eventstream to ingest the data from a Python application to our Lakehouse table. Now for the demo data set, what we are using a flight details open API. That is something that hits and it gives us some information about the flights, the departure airport and arrival airport. So we are just using that data for this demo. And we are using a service called Eventstream. Now, this Eventstream service is a new service that got introduced in Microsoft Fabric. And now it is not exactly same, but we can just think of it as a combination of uh, Azure Stream Analytics and Event Hub that we already have as a PaaS service in Azure. So when we use the Event Stream, it can receive the data, and also it can do minimal transformation on that data, and then it can send it to our destination. Eventstream will send the data to our lakehouse. Now, once we got the data in the lakehouse, we are free to, use it in our Power BI report. So that is something we are going to do to it. This is the event generator that we have. It's a Python application. So you can even, use it at your end. So for that, you just need to create an environment file, and you need to give a connection string and event hub name. So in the connection string, we can basically go to the custom app. So let me just go back to the Fabric. So if I go back to the Fabric, and this is the event stream that I have created. Now in the event stream, what I basically did, I just create a custom app. Now this custom app is nothing but you are basically creating an endpoint, and that endpoint you would like to expose it to the other application to send the data to your processing engine. So this is the app that we have. So in this app, we are going to get some primary key and some connection string, and this connection string is exactly same like the way we get it in the event hub. So according to that, what we need to do, we need to put those connection string and the entity name. Like in the connection string at the end, we would be getting a GUID, entity name is equal to something. So that entity name is going to be our event hub name. So that is something we can just put it in a .env file, and that .env file should be in the root folder structure, like the way it is there. So we can just have the env file here. So we are now going to the open sky.network.org just to understand in last 1 hour how many flights were departed and how many flights were arrived. Now, according to the response that we are getting, what we are doing, we are just creating a JSON schema. And this JSON schema, we are basically sending it to our event stream. Now, event stream, after running this, what would happen? Event stream is going to get the data, right? So let me just run this one. So we got around 355 information, and these are the information that we got, like the flight name, uh, the time when we got the response from the flight, when it was departed, when it is going to be arrived in the next airport, and the airport details. All right. So now let's go back to the Lakehouse. So now once the data is being received in the event stream flight, what it is going to do, I'm just having two destination. One destination is a KQL table and another one is a Lakehouse table. Now about the, while I'm just saving it to the Lakehouse, as I was explaining, we can do uh, minimal transformation on the data that we are receiving. So before saving it, we can actually do some sort of transformation. So this is something we can do it from here. Now, when we got this data, I'm just filtering it down that, okay, if the arrival airport is null, please do not, or blank, please do not enter that data to my final table. I'll quickly do one thing. I am going to go to the Lakehouse and then just try to query the data, and then I can see that, 4,204 records are there. I just have just run the script here to ingest few set of data. Okay, so it's now ingesting 360 records. So let's note it down. So it just ingested 360 records. So we'll just give it some time and then see, like, whether it is incrementing or not. So previous count was 4204. So let it happen. And then I'll just try to show you, okay, if I would like to do some sort of reporting, right, how I can do it. So for that, I can just quickly open a Power BI report, Power BI desktop. And then this is a SQL endpoint. So this SQL endpoint means it's directly connecting to the lakehouse. So whatever is happening in the lakehouse, the current state, we would be able to see if we can query the SQL endpoint. So we can just go to the get data, and we can, since we are going to do the direct query. So for that, we are going to use a Azure SQL DB connector or Synapse connector. So let me just do that. Okay, so I'll just use the Azure Synapse Analytics connector, and I'll go back to the setting and copy this connection connection string, put it here, and I'll just say that, I would like to do the direct query. Okay, so I'm just able to see it. So let me just input this one because I'm interested here. Okay, so I got the data, and I'm not going to do anything fancy here. So I'll be just looking at the count so that we can understand whether the data is being reflecting in Power BI or not. Okay, so I think we could see that it's now 4505. So the previous count, I believe it was 4,200 or something. It got increased 4505. I believe lately some more data got inserted. Okay, so there is a reason why the count is less. The reason is that in the event stream, I was doing some filter, like, arrival airport is null, then it should not insert the data in my destination. But at the same time, I was doing one more destination from the event stream to the to the cake well, where I was not applying any sort of filter. So then if I just go back to the cake well, probably I'd be able to see all the data got ingested. So if we just go to the cake well DB, it is again, this DB can handle, like, huge amount of time series data or the real time data. So now here also I have this flight data cake well. So total count of the records, and I can see is 5190. So that means more data got ingested in KQL, because in KQL we haven't applied any sort of filter. So quickly go to the KQL destination. Whatever we are sending, it is just getting inserted into the KQL database. Okay, so we'll now move to our next use case. We are going to have the same similar type of Python app, but this time instead of event generator, instead of the event stream, we are going to send this data to a event hub. There we are going to have a notebook where we would be writing few streaming code, which will read the data from the event hub, and in a micro batch manner, it is going to send the data to a lakehouse. And from there, we would be doing the Power BI reporting. Now, the Spark structure streaming is a open source project from Spark, and it is really useful for any kind of streaming pattern. Now, we looked into the pattern one, and as I was explaining, in pattern one, we are able to do very minimal transformation like filter, aggregation, and all. But let's say if we need to do some sort of derived column, or if we need to do some sort of complex aggregation, right? So then code is always flexible. So for that, we can actually use this structure streaming. Now, if I show you the code, the main portion of the code, right? Here we can basically see that we are reading it, and we are doing some sort of transformation, and then we're just writing it to a destination table. So before I get into the code, let me just talk about few important point about, like, the consideration that you need to make while you are working with the structure streaming. So about the fault tolerance. Now, it might happen the notebook that we are running, it can get stopped due to different region, right? So we should be having a mechanism by which we can retry the notebook and start the notebook, in case it got cancelled or failed. So this is something we would be able to do it from the area, from the pipeline that we have in Fabric. So from the pipeline, we'd be calling the notebook activity, and then we could just place the retry logic in that activity itself, giving a interval of 30 seconds or 1 minute. Secret management, from Spark notebook, we can call the key vault, and from the key vault, we can gather the connection string or any secret information that we have. The third one is the micro batching, and micro batching is important. Because if we do not do the micro batching, what would happen? This Spark streaming is going to do the event by event operation. Now, if in micro batch, what it happened that if we just put a window of 10 second or 15 second, in that particular window, whatever the event happened, it would be taken as a group and would be processed together. So the overall response time or overall performance of the uh, structure streaming code is going to be very fast. Okay, while the event generator is running, so let's look into the notebook, and let's understand the building blocks of it. So let me just go to the notebook that we have. So as we can see, the source is the event hub and destination is a lakehouse table. Now here we are just reading some key vault name and secret. We are calling the key vault secret to get the event hub connection string, because that is where our data reside. We are providing two paths. One path is obvious, is a destination where we would be sending the data, saving the data. And then another one is a checkpoint location. Now, so this checkpoint, we can just think of it as a watermark. Now, looking at this checkpoint, the Spark streaming job would be able to understand I have processed, till what point of time and what I need to process next. And this is the extra piece of code which is required. Let's say, if we would like to run this job from the beginning, right? What would happen that every time this job will run, and the checkpoint is going to be propagated towards the real time or the current time. Now, let's say that something happened, data got corrupted in the lakehouse, or I need one more output from this Spark streaming job. So in those kind of scenario, we can just put a start time offset, and then we can start reading the data from the beginning, provided that you have the retention policy set, even have correctly. Because let's say that in event hub we have the retention policy of 1 day, then what would happen, this offset will not work, because after 1 day the data is going to be deleted at the source. So this offset will be always applicable considering that the data is present at the source, not deleted. Okay, so I'm just getting that connection string in the event hub, And then I'm starting reading the data from the event hub, providing that event hub configuration. Post that, looking at the source schema, I'm just um, I'm enforcing a schema here, and then whatever the data that I'm receiving from the event hub, that I would be receiving as a JSON file. So I need to convert that JSON file as a tabular data set, right? So this is something I'm doing it here. Now this is where the actual transformation is happening on that read data frame. So as I was explaining that, and I'm going to do a micro batching. So in the, for the micro batching, what I've done, I have just defined a method. So this method is going to be called by this for each batch every time. Now here, this is how, we would be able to ingest the data from a event generator uh, to our Lakehouse table. So now I was just, use this, and 386 records got, inserted. And let's look into the data quickly. So I will go to our SQL endpoint. Okay, so 2241, and we'll just have a look on the count later. Okay, so 372 is the count. So we are adding 372 records, and let's just have a look now. I think we just need to provide some time. Okay, so I think I was just testing it without even running the notebook. So I should go and run the notebook first. Otherwise, obviously, the processing will not happen. So what I'll do, instead of running the notebook from the notebook, I'll just go to the data pipeline and just run the notebook from here. So I just have a notebook and I put the retry logic here. So in 30-second interval, it will try 3 times. If the notebook had any problem, or so, let me just run this quickly. So what it will do, it will just run that notebook that we have that we have pointed in this activity. And I believe now if we go back to our SQL endpoint, we would be able to see the correct data. So let's see. So we had the 2441 count, 372 will be ingested. So just, so as you can see, the data got updated now. I think few more, because I was not running the um, notebook, but I kept on ingesting the data into the event hub. So whatever was left over from the last run, so it just took everything together in one batch and just processed it. So this is how we can use the Spark structure streaming to ingest the data from event hub to the Lakehouse table. So let's get into our last pattern. So in this pattern, it is exactly same as the pattern 2. But the difference is that, instead of the event hub, we have some storage account, some smaller files kept in a storage account. Now these files are being generated by some app. It might be IoT Hub, or it might be, we have a feature called capture event in Event Hub. So using that feature, we can save the data, or we can consolidate the data every 5 minutes or every 2 minutes, and keep the data in the storage account for the historical purpose. Now from there also, if we need to do some sort of streaming or some sort of ingestion, how can we do that? Using the watermark approach is something definitely we can do, but it's a very tedious job, because just assume that every minute if we receive 100 or 1,000 of files, using the watermark approach is not going to be that efficient, because we need to keep on running the job every 5 minutes or every 10 minutes, which is not good for any kind of batch event. So then, for to avoid those kind of problem, or to mitigate those kind of problem, we can leverage the Spark structure streaming for the CSV files. Now here also it will keep the checkpoint, so it will basically put a mark that till this CSV file I have already processed. Whatever coming next, I'll just take it in a batch and I'll just process next. So that's how it basically happens. So we'll quickly finish this demo. So for this as well, I got one script which I'm going to run. So let me just go back to this generate streaming input file. So here what I'm just doing, I am generating 10 files, and probably I can just give 1 second to be waited. So every 1 second it is just going to generate one file with some dummy schema, name, age, and country. So let me just do that. Let me just run it. Okay, so now we can basically see that the files are being uploaded. So we'll quickly go back to our destination in the source container, and we can see that these files got generated right now, right? So what we'll do, we'll just go back to we got some new files, right? And then we are going to have one more notebook. So let's understand about the notebook code, and then we'll just run that notebook to see if I'm receiving the new data or not. Okay, so I'll just open this notebook, and all the notebook that I'm running, everything is there in that block. So please follow that block, and hopefully you'll be able to get all this code there. So now in the notebook, what I'm just doing, I'm defining, you know, three file path. Obviously, it is +1. That is because I need to provide the source data folder. Last time in the pattern 2, I was just providing the even have connection string. And if there is any existing file, I'm just deleting it. Now it is only required if you would like to start the job from the beginning, right? So then you would like to wipe out everything and reload it. Um, then here what we are just doing, we are read streaming it, but we are just streaming it for the CSV file, and we are providing the separator and the schema also we are defining. And then we are doing some sort of transformation on the data that we have got from this spark.readstream. We are just adding file name uh, as a derived column, and also the timestamp to understand when this file or the data is being ingested into the Lakehouse table. And then we got this write stream option, similar to what we did in pattern 2. Once we got this data frame, and we keep on adding this data frame to the existing table that we have. So now we got this data. So what we'll do, we'll quickly go to the SQL endpoint and see that if we are able to read the data. Okay, so now I'll just quickly go to the schema, I think. Okay, so we basically have 19 files and we ingested 10 file. So now what we'll do, we'll just go and run the notebook, do the run all. So what would happen, it will continuously be running. Yeah, so it is running right now, and we'll again go back to the SQL endpoint just to see if it is ingesting the data. So 19 files we had. So I'm expecting to see 29 files because we just ingested 10 file. So let's see. Yeah, so we now got the 29 files. Now, okay, so this is how we would be able to ingest the streaming data into our Lakehouse table. I hope that it had helped you to understand the streaming concept in Lakehouse and using Microsoft Fabric. Thank you so much for watching.